Good morning. This lecture will discuss cellular manufacturing. In particular, what I will be doing is I will be showing from start to finish a video which records the conception to implementation and operation of an assembly cell at a company called Milwaukee Electric Tool. Even though Milwaukee Electric Tool assembles products in this video, they also make a lot of machined parts inside, and they of course get other parts from their vendors. I personally believe that this video teaches all the best practices that must all be implemented in order that an assembly cell can literally operate like an autonomous business unit. So here's what I believe is the strength of a manufacturing cell as the building block for transforming any and every high-mix, low-volume manufacturing facility. First, there is focus. A manufacturing cell has focus. Why? Because the sales team can complete and ship any order for any part or product in the part family assigned to the cell. And it could be for any quantity, to any customer, as long as they are able to hit the delivery date. Second feature of a cell which is operating as an autonomous business unit is flexibility. The cell can produce any part or product in its product family. Now, somebody might say, well, that limits the flexibility of the cell, but please understand again that lean in assembly is different from lean in high mix, low volume. So in high mix, low volume, product families tend to be much larger, a little more diverse, and the manufacturers are able to handle the variety of product inside a product family. This is not like an assembly where you have a very limited number of product variants which constitutes a product family. So the second capability or offering of a cell is flexibility. The third offering of a cell is a continuous improvement culture. What does that mean? The sales team has full authority to do projects to achieve standard performance metrics set by management. And these metrics pretty much are represented by the acronym SQDPC: safety, quality, delivery, productivity, and cost. So the culture basically is where management has given the authority to the team that works in the cell to go ahead and make the improvements that they wish to make. And at a certain point where they find that they need bigger projects to be done for them to achieve the next level of improvement, that is when they step up to management and say, we need more help. Can we have your internal industrial engineer or Lean Six Sigma champion work with us? The fourth capability of a cell is accountability. The cell is responsible for producing any order for a particular product family from start to finish, and essentially that group of employees is held responsible for meeting the performance metrics that they agreed to when they met with management. So there's an accountability. The sales team is responsible for achieving those metrics set by management. They're held responsible, not in a violent or brutal way, but when there are meetings, say a morning huddle with a member of management or the plant manager or the vice president of operations, maybe once a month. There is always that session where the person in management says, okay, these were the metrics we said, the ceilings were this value, here's where you stand, below, above, what do you plan to do with where you fall below the metrics and where you fall above the metrics. Good for you, keep up the good work. We appreciate what you're doing for us. And then finally, the most important, personally I feel, attribute of a cell is ownership and autonomy. The sales team has full authority to establish cross-training programs, have a say in who gets recruited to work in their cell. They can partner with other cells to share resources as and when needed. They can communicate directly with customers and suppliers. They can determine who does overtime on which days. And I must say that this particular video, produced by the Society of Manufacturing Engineers, is perhaps the best one I've seen in many years from them. They've made others, but I find that when I talk about cells, this video gives me that complete look into a real world situation that I can then discuss. So from my own experience, Let me share with you the metrics we recorded when we implemented this machining cell. Now, a machining cell is more of a job shop. It does a high variety of product, and it doesn't do everything in assembly, step one, step two, step three, step four. So here were the metrics we recorded when we implemented this machining cell. Order flow times were reduced from 16 days to 5 days. They could turn around an order within 4 to 5 days. The standard lead time they quoted to customers was reduced from about 20 plus days to 10 days. That's almost like from 3 weeks to about 1.5 weeks. The annual labor hours which was spent on material handling to and from the cell was reduced by about 51 hours. So the designated material handler, when we measured their time before and after, we pretty much freed up a lot of their time that could now be allocated to other areas of the facility, for example, in receiving and shipping. The U shape of the cell had the machines on the periphery, and the tables for cleaning, inspection, etc. were in the center. So that means the parts were manufactured on the periphery as they followed machines in a U shape, but then inside the cell, we put all the inspection and cleaning and other support work. So imagine a W. So the U is the outside, and the middle line is the middle of the W. And all flow of material was counterclockwise and streamlined. So we never had people falling over each other when they moved inside the cell. The cell's area was reduced from 2,816 square feet to about 1,410 square feet. That's almost half the area. And because the cell was compact, there was a good result that the amount of clutter and the tendency of the employees to just leave things on the floor or to allow big containers to be brought into the cell, that was eliminated because there just wasn't any space for them to put all that extra stuff which they tolerated before we went and did 5S as a precursor to implementing the cell. The distance traveled by any order processed in the cell was reduced from 618 feet to 368 feet. So again, this was giving the cell the ability where an operator could literally pass the part by hand to the next operator. Earlier, just because the machines were reasonably far apart, the way they operated was the parts came in on a container and the operator dutifully went through each and every part, and only when the entire batch of parts was completed, then they went and looked for a pallet jack and then trucked that container of parts to the next machine. And finally, the line of sight efficiency, there's a way to measure this metric. It improved from about 29% to almost 70%. So the benefit was that this metric essentially captured the fact that any cell employee could see the progress of work on any day and quickly communicate with other employees. Anybody standing at any machine would know what the other person was doing, and they could track the progress of any order. So that's like an introduction, and now let me go ahead and play the video.
Manufacturing Insights, Manufacturing Engineering Magazine's video series for process improvement. This program examines customer-focused manufacturing at Milwaukee Electric Tool and the diverse management techniques they use to improve an already successful company. For the last 20 or 30 years, American manufacturers have struggled to find new ways to make their products better, faster, and cheaper. In short, to make them competitive. Some succeeded, others did not. This program looks at one company that succeeded through a customer-focused transformation of their manufacturing system. It is the story of Milwaukee Electric Tool Corporation, a manufacturer of portable electric power tools based in Brookfield, Wisconsin.
Do you see the sheer variety of the products they make? That's amazing. So no wonder they had about 30 cells totally implemented inside their facility because there just was this large range of assembled products. And now you can think about the sheer variety of components, machine fabricated, injection molded, pretty amazing.
Though well managed and profitable, the company chose to completely reorganize itself with an eye to ensuring profitability and superior customer focus over the years to come. After some U.S. manufacturing organizations woke up and avoided disaster in the 70s, dozens of new production and manufacturing concepts emerged. Just in time, total quality management, world class manufacturing, Kanban, Pokoyo, Kaizen.
I hate to mention this, but today the crisis which we are suffering or living through, the COVID-19 crisis, to a great extent, we are going back in history and we are facing the same hardships that we faced decades ago when essentially, the recession hit and work was being outsourced to China, and then we learned from Toyota and we tried to bring back manufacturing. But the sad part is that all these buzzwords, to me, reflect the failure of the industrial engineering profession, both academics and practitioners, to take charge. All of these are called buzzwords, essentially were inspired by Toyota. And somehow that company and their process engineers and their senseis, especially Taiichi Ono, they figured out a certain form of industrial engineering, and we call that Toyota style industrial engineering because it actually works as opposed to what we teach and what we do research about, which is mass production industrial engineering, which we all know has no place in the world today. So, what I would like you to understand, please, is that things like flexibility, agility, lean are just buzzwords. And at the end of the day, somebody, a group of people, industrial engineers, have to step up and teach the rest of the world how to formally introduce these best practices and simply call that good industrial engineering.
Agility, cellular manufacturing, re engineering, and many more. These concepts can be confusing, both in which methods to select and how to implement them. Most companies that have successfully reinvented themselves share a common attribute. They investigated many improvement concepts and picked what suited their needs, then ignored the rest. Milwaukee Electric Tool is one such company. Milwaukee decided it would implement just in time production using a cellular organization, with its workforce focused on continuous improvement. Here's how and why they went about it. Most manufacturing companies reorganize themselves because they have to, often because they are in danger of being engulfed by the competition. Milwaukee Electric Tool reorganized because of the changing needs of customers. To better serve all customers, a more flexible, short lead time system was needed.
So the point here is that, at least in my personal opinion, is that when you implement work cells, if you correctly design them where the purpose of each cell is to start and complete processing of a group of products, you are essentially driving what you do under the umbrella of continuous improvement rather than saying, let's go do continuous improvement, let's pursue waste elimination, let's implement Six Sigma. What here you're saying is that let us create a completely new way for us to work within the four walls of a service business or a manufacturing business. And as long as we decide the scope of organizing a portion of our business to be a work cell, automatically then we'll be driven to undertake the appropriate continuous improvement projects to make that cell work as an autonomous business unit. So please understand, reorganize with a purpose that if we can allow one area of the business to be completely executed in one area of the facility, we could not be any better at customer satisfaction.
To maintain a competitive position, waste in all forms was targeted for elimination. During this reorganization, Suppliers were encouraged to be a part of the changes.
That's very, very important. Suppliers are encouraged to be a part of the whole transformation. And a very simple way to do it is take the products that you think you would like to produce in a work cell, obtain their bills of materials, and simply do a classic MRP type of explosion. And then understand which suppliers are responsible for which parts, either purchased parts or vendor processes. And that's a simple way to include them in the extended team that will not only design the cell, but then support its operations.
And adopt similar systems. To achieve flexible production schedules, employees needed to be cross-trained. After making these changes, Milwaukee's ultimate goal was to drastically reduce its lead time and be able to ship.
Cross training, once again, it is one thing to say, let's just go cross train everybody, and everybody gets to choose what they wish to be cross trained in. On the other hand, if strategically you say, inside this cell, people need to be able to be cross trained, and this is the bottleneck process, so therefore we need at least a two deep or a three deep level of employee capability. If somebody falls sick or somebody leaves the company, we will still have somebody who is very conversant in operating these machines. The cell basically tells you who should be cross trained to do what. And it all comes and builds around what are the products we make, what are the processes we use, what kind of inspection is needed, which suppliers are going to be involved. Appropriately, you do cross training with that boundary of what cross training and how much cross training needs to be done.
Smaller quantities of a wide variety of products more frequently, all with zero defects. The company views its move from traditional batch type manufacturing.
Question to you: why do you think that in a U shaped work cell configuration, the potential for quality defects to be passed on to the final product pretty much go to zero? Why do you think so? Send me your answer later.
To one-piece flow manufacturing as creating not just a new manufacturing system, but an entirely new business system.
A new business system is more than just a manufacturing system. Many of the elements of cellular manufacturing will, of course, produce results in the manufacturing area alone. But this is more a business system embraced by all levels of management.
The first step in implementing the new system was taken by executive management. The company president talked to all employees to make sure they received a clear understanding of the company vision.
You see, this is very, very important. It's not just, you know, the vice president of operations or the CEO just coming in, serving pizza, and say, guys, we're going to be implementing lean. Guys, we will be implementing sales. In my own experience as a consultant, what has always succeeded is where the person in power, like a vice president of operations, a director of manufacturing, and of course the plant manager, they were the ones who learned what needed to be done, and then they were the ones who championed what needed to be done, and they even became teachers and mentors to their employees before they allowed others to take over those responsibilities. So that involvement and that this is coming from the top, and executives firmly believe that this is where we wish to go, and then they themselves participate rather than just delegate the responsibility of learning and implementation. Those play a very strong factor in the success of implementing any part of the lean Toyota system.
Mission, goals, and what changes were about to happen, and why. Next, key managers were invited to in-depth training sessions on all the concepts involved, especially cellular manufacturing and the Kanban inventory control system, both of which were at the heart of the new system. The next step was to form the first cell. Once its basic design and staffing levels were determined, cell members began an extensive period of training.
When we decided to implement cellular manufacturing, we had a vision of what the finished product would look like. We did not have a detailed plan, but we did have a sequence of events that should occur. Identification of the product, gathering of data information to determine the size of the cell and square footage, the type of equipment required, the number of employees, type of skill, and the like. Once this was done, the equipment to be included in the cell was identified, and the operator under our whole pay system was allowed the opportunity to join that cell as the incumbent on the equipment or workstation moving into the cell. And once this group of people was determined, the training process for them began.
Throughout the entire cell implementation process, the company adopted a complete systems approach, avoiding the error of making changes in a piecemeal fashion.
Many of the elements of cellular manufacturing or just-in-time manufacturing do produce results on their own. But our service to and satisfaction of our customers are too important to be treated as a piecemeal project. And therefore, to concentrate on our customers and our employees, we wanted a complete system that worked together to give us a world-class system of manufacturing, both for customers and for employees.
Although a cell can be created and made operational in a few months, bringing it to its full potential takes time. Training, coaching, and counseling are required to bring about the needed changes in work culture.
We actually made the physical change in about 3 months. 53 working days it took us to make the physical change is in most cells. But it took another year or two through the discipline of learning and applying and repeating each step in the process.
Milwaukee Electric Tool currently has some 30 cells in operation. Most manufacture complete products like saws or drills. 2 cells, however, are dedicated.
So this is very important that this facility, Milwaukee Electric Tool, clearly is a vertically integrated facility. So they make machine components, and then these machine components are distributed to any number of assembly cells depending upon the product's requirements for those machined parts. So again, I feel that that tells you that there are 2 flavors of lean. One flavor is the final assembly cells, which would operate mostly like mixed model assembly lines. And then the parts production cells, which literally would operate like job shops. So there are schedules set up for them, and they work to fulfill those schedules regardless of which particular assembly cell said that they needed certain parts. But the challenge here becomes that every assembly cell will need a kit of parts. And if these parts are coming from multiple cells, there has to be quite a bit of effort and attention given to implementing scheduling. So things like water spiders, parts supermarkets, finite capacity scheduling become extremely important. That's a separate topic, but all I wish to caution you about is that there are at least 2 types of lean. One is the assembly lean, and the other one is the high mix, low volume components manufacturing lean. Now, how you organize for the components manufacturing lean is left to the individual implementer's priorities.
To producing gears, and 2 others to producing motors. Implementing each cell at Milwaukee is accomplished by a detailed 53-day timetable. On day 1, a cell facilitator is appointed. By day 3, the process of collecting data has started as to how.
Do you see how amazingly well organized this machining cell is? Clearly, she is making individual components, but I see only one person who's essentially walking parts to different machines. Now, I don't know, but I'm sure they'll have more people come into the cell if the demand for parts on the cell increases. But this is again a machining cell. So this is probably the gear cell or the rotor cell or the shaft cell.
The work will be distributed within the cell. Day 5, determine equipment needs. Day 9, determine staffing requirements. Day 11, determine the physical layout of equipment, benches, and material. Day 12, conduct orientation and begin training of key cell members. Day 15, Develop the Kanban or pull system of inventory control. Day 19. Determine requirements for additional equipment, such as tooling, fixtures, and material handling devices. Day 22. Develop the pull mechanisms under which the Kanban system will operate. Day 29. Establish the elements of a visual workplace. The cornerstone is the 5S control system. In Japanese, these all begin.
If I may break from the speaker, personally, I believe that 5S should come way in the beginning because only when you do 5S, and remember from a previous lecture, there are three questions you ask about every item that is going to go into the cell. Do we use it every day? Well, keep it at the point of use. We do use it, but we do not use it every day. Keep it inside the cell, but on the periphery, so it can be accessed whenever it's needed. Three, do we even need it at all? No. Either get it out of there, trash it, scrap it, or put it someplace where you can get to it if ever you need it. So that's fibers that way is going to give you a sense of how much am I going to put into this one area. That is going to be where the cell operates. So I would not wait this long for the 5S work to be done.
With the letter S. In English, they are clearing up, organizing, cleaning, standardizing, and discipline. Day 39. Orientation and training begin for all cell members. Day 45. Meet with vendors to establish a Kanban pull system to minimize lead time.
This is extremely important, especially as you become a small or a mid-sized manufacturer, because your vendors are not completely getting all their business from you. They essentially keep you as one of several of our customers, right? And so that results in compromised quality, that results in compromised production capacity that they allocate to you, that results in compromised delivery dates, the extent of expediting they're willing to do for you. So keeping the suppliers involved in the cell implementation process, possibly even helping them to implement work cells in their manufacturing facilities and other improvement practices that they learn from you is perhaps the best way to have a partnership with your suppliers.
Day 49. Clear floor space for the new cell. Remove all work in process not immediately needed. Day 53. Move in equipment and arrange cell according to plan. Set up the cell control board, listing these production benchmarks: output, on-time delivery, inventory on hand, scrap and rework, continuous improvement projects, manufacturing cycle time, and cycle.
So you can see here that they've actually put 7 metrics that should be tracked in a cell. Again, please understand that the more metrics you have, the more data has to be collected, and the more data that has to be collected, the more people are going to be forced to do necessary but not value-added work. But if both the people working in the cell and management arrive at the understanding that yes, these metrics are important for us to be held accountable and for us to be incentivized, for us to be rewarded, then there is a balance between data being collected, data being tracked, and performance being rewarded.
Count accuracy. Getting a cell up and running is only the first step. The real proof of a cell's success is the cell member's ability to continuously improve performance, even if only in small ways.
Most important part of cellular manufacturing.
So this is very, very important. The plant manager. Again, in my personal experience, because I tend to work with small to mid-sized companies, more than the director of manufacturing, the plant manager has to be really savvy about lean. A plant manager has to be really motivated, and they really have to put pressure upon themselves to learn, to master, and then actually help with implementation. If this individual is somebody who's like, well, you know what, I've got 2 years to retirement, who cares, right? You're sunk. Or if this person is like, nah, I am happy working in the old ways, and I do not need anybody to tell me about lean and Six Sigma and theory of constraints and whatever. it's not going to happen because the subordinates will take their cue from this person. So I always look for, the individuals who I will be looking at, like, look, I gave you some good ideas. I taught you what to do. What did you do with it? Do you now think about implementing what I told you because you think that that will benefit your operation? This individual is extremely important.
Is the idea of continuous improvement and the fact that you should never be satisfied with the level of performance that you've achieved. Change in under cellular manufacturing is very important, and you don't need dramatic change every day. What you need is small mounting change on a day-to-day basis. In other words, the real key to cellular manufacturing is making sure that you're making improvements every day and that you don't view those improvements as an interruption to production. You view those improvements as a small investment that you will reap benefits from down the road somewhere.
By design, all the cells are U-shaped to bring each.
So you can see that the U is very obvious. So work starts on the right side and progresses up into the screen and then turns around to the left and then comes back. All the packaged boxes are on a pallet waiting to be shipped. The importance of the U is that all the value adding work gets done inside and all the outside logistical support gets done outside. A strong recommendation to all of you would be the Lean Enterprise Institute has published a book, and it's one of the 5 in the series that leads off with the book Learning to See, the book on value stream mapping. This particular book is titled Creating Continuous Flow. And even though it discusses a very simple single product assembly cell, the level of detail is wonderful, and I strongly urge you to master that book, besides, of course, the other books.
Machine and operation within easy reach of all cell members. Parts and assemblies move in a counterclockwise direction, one at a time, eliminating inventory buildup between successive operations. When a finished part or assembly arrives at the last station in the cell, it is complete and ready for shipment, either to the customer or to another cell.
Communication is very important, especially if there's any kind of a problem during the assembly process. In a traditional straight assembly line, the person at the end of the line would have to try and find their way to where the problem would be, maybe backtracking. And in U-shape, it's just real easy to just turn around and solve the problem at its point.
And the other important thing is, see, when you tie that into accountability and performance measurement, that communication will automatically follow. So if the metrics basically say we will measure the team on these measures of performance, there will be none of that fault finding and blame passing that typically occurs when you have what is called a functionally organized organization. So communications will automatically happen if you put a team in proximity to each other and you essentially give them responsibility for products that actually get sold to customers, and you hold them accountable for the work that they do and the quality of the work they do and the orders they fulfill.
Counterclockwise is traditionally set up for the right-handed person. As you move in a counterclockwise motion, the right hand actually picks up the part and does the assembly as you continue to move to the left.
The cells at Milwaukee Electric Tool are self-contained entities. Each cell controls not only all its own manufacturing, but all support activities as well. These include scheduling, interfacing with vendors, manufacturing and industrial engineering, tooling and quality control. Each cell member is asked to be certified in at least 3 value-added jobs, plus some additional non-value-added jobs. Therefore, when sales are high, most cell members work in value-added jobs in order to fulfill shipments. In a lower sales period, more cell members work in non-value-added jobs, like preventive maintenance, gauge calibration, repair, or upgrading of equipment. A brief meeting of cell members at the start of each shift permits exchanging information, including identifying problems, deciding the best way to solve them, and selecting volunteers to make the necessary changes. During production, As problems surface in the cell, they are handled internally.
So once we identify a quality issue, we put together what we call a problem-solving team, and we use the problem-solving process and the quality improvement process, where the cell members themselves collect the data, they identify the problem, they come up with certain solutions, we implement those solutions, and then we reevaluate it. If it doesn't solve the problem, we go back to the first step. But the cell members themselves come up with the solutions and implement them.
So I again differ on this opinion. I believe that there are not enough good industrial engineers out in the workforce, and that too many companies are giving the responsibility of good industrial engineers to some Six Sigma belt, green belt, or yellow belt, or some lean certified individual. Uh, Performance suffers. So I personally believe that universities have to better train their students to be good industrial engineers, and then when that is accomplished, manufacturers should prefer to hire industrial engineers who can not only do the data analysis, but they also understand what I would call the Toyota style industrial engineering. So they know both the analytics and they know the practical, and they are the ones that are relied upon to support individuals like this gentleman and other problem solving teams.
All Milwaukee facilities maintain ISO 9000 certification and practice a total quality control management system. To ensure all processes conform to requirements, process capability studies are performed and corrective actions are taken if necessary. To support continuous improvement, cell members receive problem-solving training, including the use of Pareto analysis and cause and effect diagrams. Other quality techniques include simple mistake-proofing devices, like this red and green stick, that can determine quickly if product assembly is correct. When quality problems are encountered by anyone, such as when non-conformities are detected, a red and-on light indicates a line shutdown has occurred. With every operation, the plan, do, check, act routine is used to help improve the next production cycle. With the focus on the customer's needs, controlling the production and scheduling of the cells relies heavily on the determination of takt times. The word takt comes from a German word meaning rhythm or beat. Each cell calculates its own takt times using a simple formula. For example, an 8-hour shift consists of 480 minutes. Subtracting 2 breaks and 1 daily meeting leaves a net operating time of 450 minutes per shift. If a customer's monthly requirement is 9,000 units and there are 20 working days per month, the customer's requirements equal 450 units per day. Applying these results to the formula produces this result. The cell members now know that they must produce 1 part per minute to satisfy the customer's requirements. This information tells the cell members how many machines and machine operators must be assigned to production to meet this goal.
That time is probably one of the most important aspects of cellular manufacturing because it's a measure of how we define our customers' requirements.
An important element in the operation of each cell is the use of a Kanban pull-type inventory management system. Unlike traditional push systems, where inventory is manufactured according to a schedule planned far in advance, the Kanban system produces items only as they are needed, or to replace items already used in production. With Kanban, material is not issued until a signal comes from the user of the item.
Kanban becomes very important because it's our material management system. It allows us to know when to replenish material based on consumption. Behind us, we have the Kanban board. This half of the board represents all the material that we have in our distribution center. The other half is the material that we need to produce in order to satisfy our customer sales. As a customer orders material, it's simply, when they order that 150th piece, the card will come off, and it'll go to the Kanban board, signaling it to be replenished. Gives us the ability on the board to sequence the jobs rather than having dates. We simply work to replenishing the oldest part. Board, the arrow functions in a left to right, top to bottom motion, so that the last card hung on the board becomes the last card to be produced.
A few simple rules govern Milwaukee's use of Kanban. No work can be started without a Kanban card. Standard containers are always used and filled to the required quantity. All containers must have Kanban cards. The number of Kanban cards in the system indicates the amount of work in process. Efforts are made continuously to reduce the number of cards in the system. In addition to using Kanban internally, each cell has established a Kanban system with its vendors to ensure that material arrives only as it is needed. The cells also have ongoing programs with suppliers to identify and resolve all problems relating to product quality.
Other factors involved in making this change really involve bringing our suppliers in and training and showing them what we were going to change in terms of how we would run our production. Now they understand that we're focused on delivering mixed products every day instead of just setting up a line and running 2 months worth of a given product. We try and run a day's worth of every individual product that we're responsible for. They need to be able to ship us a variety of parts on a day-to-day basis instead of large volumes of individual parts. We need a mix of parts every day. So we have involved them to help us make this change.
A key part of management's thinking behind these changes was the desire to avoid exporting any part of its production solely for cheaper labor in other countries, to preserve the jobs of its dedicated workforce.
Our company has been in business more than 70 years. Of course, over that time, we do have employees that are second and third generation. The long tenured employee has helped grow this company and helped serve our customers for a long time. It is an investment in the future to ensure that they have good jobs with good opportunities, career advancement, ample training, and good benefits so they can be very productive so we can grow and serve our customers in the future.
Moving to cellular manufacturing has had a dramatic impact on employee performance.
The performance of the employee has changed in a variety of ways. Not only are they more flexible today, but in many cases, they're much more involved today than they were in the past. Under this system, because you work in a cell and your cell has an identity, they produce a product. The cell members know and understand that they have to deliver that product to someone. And so they're much more involved in making the day-to-day decisions necessary to keep that flow of product constant to their customers.
All 30 cells are working toward becoming fully self-directed work teams. The responsibility for achieving the required level of training rests.
This whole concept of self-directed work teams, and there's a book out on that concept, makes complete sense. It makes complete sense. Now, again, I would hesitate to see this concept working in a union facility, but if it's privately owned, this whole concept that you develop your employees and you respect them to basically run with the responsibility of operating a work cell is fabulous. Is absolutely fabulous.
Primarily with individual cell members, with support from other cell members and plant management. The ultimate goal is the establishment of a highly flexible workforce that is able and willing to perform all tasks needed each day. This goal is being reached through Milwaukee's unique Pay for Knowledge program, whereby as employees achieve additional job certifications, workers move to higher pay levels. Traditional payment plans are based on individual job classifications, in which employees may increase their income only within a limited range. Payment for knowledge, on the other hand, is based on the total mix of skills the employee possesses.
Yes, pay for knowledge is a very important concept for two basic reasons. One, to make this system successful, employees and cell members must be flexible, must achieve a high degree of flexibility. And the pay for knowledge system encourages them to do that and then rewards those that do that well. It is important in the system to allow direct and indirect functions to be performed to completely serve the customer with no waste. Another reason it's been very important for us is pay for knowledge and has allowed employees to gain considerable knowledge and confidence in their ability to handle difficult and complex tasks. Traditional manufacturer employees do learn a task and repeat that for many years, become obsolete when the technology changes. We do not want that to happen to our employees. We want to be able to evolve with the knowledge and level of understanding of technology in order that our traditional employees will be able to handle new technology without being obsolete and replaced by newer skills.
If I may give an example that I recently learned, you would have heard of cobots, right? Collaborative robots. These are robots which work side by side with humans. So this video which I saw showed a four machine CNC machining cell, and each machine was tended by a cobot, and it had one person. They had one person basically who sat around and essentially babied the robots. But other than that, the robots handled the tool changes, the parts moving, loading, unloading, and transfer between machines. It was fascinating, and that is the new era of machine and man, and we just have to be ready for that, especially in this pandemic period. We've kind of realized that in the interest of social distancing and remote work, we are going to put fewer people attending to multiple machines, so that implicitly they are going to be further away from each other. So whether you like it or not, that's what's going to happen. There's going to be more machine-driven work, and people being smarter than the machines, having to do more of the intellectual support work that the robots and the machines themselves cannot do. So the level of education and training is going to spike.
Under pay for knowledge, all jobs are arranged in job bands. Within each cell, the tasks are listed in order from the easiest to learn to the most complex. The pay for various elements within a band is the same, but does increase from one band to the next. Each job has established certification requirements. To earn more, a person must gain the knowledge to be certified in a new job and then perform the job often enough to maintain proficiency. It is not uncommon at Milwaukee for cell members to be certified in 6 or more jobs in several bands. An example of how the program works is a grinder operator is seeking certification in 4 new areas: hopping, double disc grinding, honing, and broaching.
Do you see that these are all the processes that typically are needed to make gears? And you had already seen earlier that a gear cell is one of the shared resources. It's like a supplier to the assembly cells. So, given that the work cell has to have capabilities and machines that perform different processes, it is but natural then that somebody who runs one machine in that cell should really learn to run other machines to qualify for the incentive plan which says, you earn as you learn. So the work cell puts a boundary around anything and everything that needs to be done rather than just what I would call continuous improvement by whack-a-mole.
All pay calculations begin with the entry-level base pay at an hourly rate. Once certified in grinding and hobbing, the pay will increase for each of these jobs by the established hourly rate added for the job. When certified in all 5 areas, the employee's pay level will be the base pay plus the hourly rate added for all certifications.
The way you would know what skills are needed in a cell is you would go to the job band file, which is in by the cell management team. You could pull out that form and you could look at it and see what skills you would need. That would tell you also you could talk to your cell manager or your cell management team, and they could also give you those answers so that you could get the necessary job or skills that you need to perform the job. I've worked under the new system and the old system, and I do prefer the new system now for the simple fact that when I worked the old system, I was always on one job. In the new system, I'm currently in 6 different jobs. I get a lot more flexibility. I can work in different jobs, maintenance, assembly, some machining, auditing. I find it more enjoyable that I don't have to sit at one place day after day and be bored. It's more exciting. I enjoy it a lot.
Pay for knowledge allows employees to earn substantially more than under the old system. but the company finds that the higher wage levels work to its benefit.
Yes, we do have a higher cost of wages than we had before, but they're more flexible and therefore more productive. They help eliminate waste to make decisions. So we have higher average wages than before, but the productivity more than offsets that. So our customers get a better value, and our employees get a reward for being flexible and more knowledgeable.
Under its traditional batch type manufacturing, Milwaukee Electric Tool was successful and profitable. After changing to JIT and cellular manufacturing, it is even more successful. In the 5 years since the new system was introduced, the company has seen these results. Productivity up by 65%. Space utilization greatly improved. Most production cycle times reduced to 2 days or less. Scrap and rework reduced by 50%. Warranty activity reduced by 48%, even though the company has a 30-day, no questions asked return policy. These remarkable improvements.
Do you just see the metrics, right? But you also see how much time it took, right? They said that they achieved these results after about 5 years. So there is a reason why everybody says, lean is about a journey. And there's a reason why you have to be very sure about the top-down projects you take or undertake to do, and the bottoms-up projects you do inside of each of those, top-down projects. And most important, the leadership has to be like the cheerleading people who, through experience, through personal knowledge, are able to say, look, I understand the hiccup we've had in this work cell, or I understand that we've had this problem with setup production or safety, but this is what we'll do to correct our actions and go forward. So that is very important. Another thing I wish to emphasize is that two words, right? They basically talked about cells and the whole just-in-time approach to production planning and scheduling. So again, no matter where you implement lean, personally, I believe that the principles of lean are absolutely always relevant. So the first principle is identify value from the perspective of the customer, what products they would like, at what price, by what delivery dates. Second, identify your product families. So each family is like a value stream. Third is you basically try to achieve delay-free, error-free flow of product in each value stream. So in many cases, that's essentially saying either implement a work cell or a line or a focused factory to produce that value stream. The fourth principle is pull schedule inside of each value stream. Do not do push schedule. And then the fifth principle is you pursue continuous improvement to continuously improve the performance of each value stream. And then you cycle back and you pick the next value stream to improve. So that is very important. The good metrics, the strategy, and the support, the knowledgeable support, and the patient execution. These are some of the common basic things you will see. Will guarantee you that at every step of your lean journey, especially for implementing work cells the right way, you will see success.
Are due for the most part to management's decision early on to empower its workforce and to allow those on the shop floor to decide what needs to be done and how to go about doing it.
It is our belief that the cell members are in the best position to fulfill customer service. They have the right information, have the right resources, and have the right motivation. So they don't need supervisors or parents watching them on a day-to-day basis. We have belief that our employees have the same interests that everybody else in the company does. It is great for morale. Morale is a very important aspect of this because it relates to motivation. Motivation to do things right because you know what's right, and to understand why things are done, and then to do them without supervision. It is not an easy thing to do, but it is a very important thing. And I'm very proud of our employees who have stepped forward and participated in the process and have made great progress in their ability to manage themselves and to be self-directed.
Despite its successes over the past 5 years, Milwaukee Electric Tool has no interest in the status quo. It is already making plans for the future.
But plans for the future certainly are a very important step to be considered because it is part of Kaizen continuous improvement. And so, yes, we always have plans for the future. One is to continue to work with a cellular principal system to enhance it and to encompass ever a broader scope of the other business functions in addition to. And second to that, it is our intent to use technology, worldwide technology, that is the best technology in the world for every country, and to bring it into our plant to have our cell members integrate that into their system. So we will then be the world-class supplier at the lowest cost and the best value for our customers.
So that is customer-focused manufacturing. That's the title of the video. But personally, I believe that that's one of the best videos I've seen produced by the Society of Manufacturing Engineers. Next, what I'd like to do is to discuss this checklist which I've created. Again, it's only a checklist, and it's been built around a lot of other people's good work. So some of these references, as you can see, even the video has been included. And all it does is it tries to tell you, look, please make sure that you do these things also, besides just putting some machines together. So how to use this checklist? The checklist consists of a set of key requirements that must be met when designing and implementing a manufacturing cell. For each requirement, there could be options that may or may not be good to ensure successful operation and longevity of the cell. For example, take the very first requirement to appoint a facilitator to manage the project. It could be led by the employee who has been chosen to be the future cell leader after it is commissioned, or it could be the plant manager, or it could be a team comprised of the in-house continuous improvement manager supported by the in-house industrial engineer, and they both report to the plant manager. That's been the way that I had worked when I was at Herbigger. And again, note that this checklist can be modified as appropriate to suit the unique operating conditions of the particular cell that is being implemented. So here's the things you need to do. Appoint a facilitator to manage the project. Determine the workload distribution on machines in the cell. Determine equipment requirements. Determine staffing requirements. Design the internal layout of the cell. Orient and train the cell operators who will work in the cell. Determine internal lot sizes. Decide on the internal containers. You want to avoid big containers and big batches. You determine the external lot size, the external containers. Those will pretty much require big handling equipment. You determine the best internal material handling. The best handling is no handling, which means the machine ejects the part and gravity assists that part to reach the next machine, and then the operator loads the part on that machine. Again, a very fascinating practice that Toyota pioneered called Chaku Chaku. Then you look at factory logistics, all the support required to run the cell. You develop a system for production control that runs the cell. You develop a system for external control. So, if the cell has to, say, get materials from suppliers, and or the cell has to share a resource like heat treatment or painting, or say a grinding cell that is shared by other cells, there has to be a lot of communication and best practices. Then you have to schedule the cell's operation and coordinate that with the vendor delivery schedules. You have to prepare the factory for layout installations, actually do the installation. You have to work on the quality assurance. Will employees take charge of quality? Will there be first article inspection done by an inspector who comes in from the inspection department? Will data be sent electronically from the cell to the inspection department? What about supervision and leadership? What about performance reporting and communications, compensation, incentives? Again, a lot of good books have allowed me to kind of prepare this master list. And again, I would leave it to you to make sure that when you implement your own cells, rely on all these sources and feel free to ask me questions if you would like to benefit from it. Thank you. That pretty much ends the lecture.